Hello everyone, in today's lecture I will be discussing a lot of important metallurgical questions. So let's start with this first one. The question is, in the extraction of copper from its sulfide ore, metal is finally obtained by oxidation of cuprous sulfide with. Okay, so we know very well that in the metallurgy of copper, extraction of copper, okay, we have copper sulfide. Okay, when it reacts with copper oxide, basically self reduction takes place. So this is termed as what? Self reduction. And this sulfide ion basically act as a reducing agent. So after the self reduction, we'll be getting copper metal and SO2 gas. Okay, so the correct answers for this should be Cu2O, that is B. Okay, so this is basically self reduction in which cuprous sulfide is reduced with cuprous oxide. Okay, where sulfide ion act as a reducing agent. Okay, let's move to the next question. Yeah, let's see this question. Nickel plus CO forming NiCO4 complex, and at 180 degrees centigrade this complex is further dissociating into nickel and carbon monoxide. The above process of purification of the metal is. So we know that nickel purification method is Mond process. So the correct answer should be Mond process. Let's move to the next question, number 7. The following reaction takes place during extraction of gold. So this is basically cyanide process. Okay, in the first, gold will make complex with the cyanide in presence of oxygen. Okay, and then we'll be using a zinc metal which will basically act as a reducing agent to reduce the gold from gold +1 to 0 oxidation state. Okay, so zinc in the extraction of gold act as. So what is the function of zinc here? Is basically a reducing agent, because zinc metal is more reactive than gold. Okay, above in electrochemical series. So basically the correct answer should be C. Okay, now let's move to question number 8. It is asking you, Illingam diagram can be drawn for. So basically we know that Illingam diagram is the representation of basically variation of standard Gibbs free energy, that is delta G naught versus T for the formation of, generally for the formation of metal oxide, but it can be drawn for sulfide, metal halide. Okay, so the correct answer should be all of these. Generally we study in metallurgy for the formation of metal oxide, but it can be drawn for all sulfide, metal halide, all, because this is just the standard Gibbs free energy change for this formation reaction with the temperature. Okay, let's move to the next set of questions. Yeah, let's see the question number 16. Which one of the following ore is best concentrated by froth flotation method? And we know that froth flotation process is basically used for sulfide ore. This process is basically used for what? Sulfide ore. And if we see carefully, galena, that is basically PBS, it is a sulfide ore, and for that I will be using the froth flotation process. Siderite is FeCO3, it's a carbonate ore, we can't use. Malachite is cupric, hydroxide, and this carbonate basically will be not used. And magnetite is Fe3O4, will not be used. Okay. Now, coming to next question, question number 17. The calamine, malachite, magnetite and cryolite respectively are. So this question is directly based on the formula of ore. Calamine is basically ZnCO3. Okay, so option 1 is wrong. Option B can be correct. Option C is wrong. Option D can be correct. So 2 options we have eliminated with only one ore formula. Now malachite is basically copper carbonate, that is cupric carbonate and copper hydroxide. Okay, so we can see cupric carbonate only, hydroxide is not there, cupric carbonate only. It means the correct answer should be D. D is going to be the correct answer. And magnetite is also Fe3O4, and this Na3LF6 is your cryolite. So basically in this question we are getting the correct answer to be D. Okay, D is going to be the correct answer in this case, D. Let's move. Next question we have. The metal extracted by leaching with cyanide is, so basically gold and silver metal is extracted by the cyanide process. So in this case, the correct answer should be silver. That is option D. Let's move to the next set of questions. Yeah, here we have some more questions. Okay, let's see this question. It is asking you the process of zone refining is used in the purification of what? So zone refining process basically is the purification method, and for the metals which is basically used for semiconductor devices like boron, silicon, gallium, germanium, okay, indium. For these metals basically we use the zone refining. So here the correct answer should be what? Germanium. Now, purification of aluminium by electrolytic refining is called. Purification of aluminium is basically Hoops process. So the correct answer should be D. Hall's process, Serpek method, Bayer's process, these are just basically the, what we can say, method of purification. Okay, extraction of aluminium basically, extraction of aluminium. But Hoops process is basically the purification method. If it's a Bayer process, in that we basically purify Al2O3. Froth flotation process basically is for sulfide ore. Hall's process is for extraction of aluminium. Okay, let's move. Now let's try this question. Choose the process that involves smelting. Okay, so basically smelting involves reduction of oxide of metal with carbon. So here it is simply heating that. Okay, there is oxygen, there is the carbon involved. Okay, and this is the metal oxide. So this is basically reduction of metal involving carbon and heat. So the correct answer should be basically the option number 3. So C is basically the correct answer for this. C is correct because the smelting involves what? Extraction of metal by reduction of its metal oxide with the help of carbon as a reducing agent at high temperature. Okay, so let's move to next set of questions. Yeah. Okay, let's see the question number 41. It is asking you that the heating pyrite to remove sulfur is known as. So suppose we have iron pyrite FeS2, and if you heat it to remove sulfur, okay, so basically you will be adding oxygen, and that process is basically roasting. So the correct answer should be D. It is simply roasting. Next, which of the following is not an example of roasting? In roasting we use oxygen and sulfide ore converts to oxide ore. So these all are conversion of sulfide ore to oxide ore. So these all are roasting. But the last one is extraction of copper. Basically it is known as self-reduction. Okay, it is basically self-reduction. It is not roasting. So the correct answer should be D. Okay, next. Which of the following sulfide when heated strongly in air gives corresponding metal without undergoing separate reduction of oxide? Okay, so for that, if you see, correct answer should be HGS. Why? Because we know that for copper, mercury and lead, okay, sulfide, we can do self-reduction. Okay, we can do self-reduction, and in this case we'll get mercury and SO2. But here it is asking you what? That if you do reduction first, roasting, and you are getting a metal HgO, okay, and SO2. HgO is basically thermally unstable. It is what? Unstable. So what happens in this case? You don't need to wait for the self-reduction. Simply it will dissociate further to mercury and oxygen gas, because this metal oxide itself is unstable. So thermally unstable means on heating, HgO will dissociate back to metal and oxygen. Okay, next. Which of the following changes takes place during roasting? Okay, so when we do roasting, basically impurities are removed as their volatile oxide. That is correct. Phosphorus is present, so it will form P2O5 and will get removed. Vanadium will be also forming B2O5 will be removed. Ore is converted into oxide. This is also correct. Changes like oxidation, chlorination takes place. That is also correct. So in this case, basically the correct answer is all of these. That is 1, 2 and 3, and the correct option is D. Okay, let's move to next set of questions here. Sulfide ores are converted to oxides before reduction. This is explained on the basis of what? Okay, so suppose we have to reduce ZnS. First we will convert this to oxide, that is ZnO. Okay, and then we'll do carbon reduction at high temperature to form zinc and CO. Will not directly reduce the ZnS. Okay, will not directly reduce. Reason being, this reduction is difficult. Okay, and oxide reduction is much easier. Okay, so that's the reason. Okay, basically, so the correct answer should be sulfide cannot be reduced easily while oxide can be reduced easily. The first option itself is the correct one. Okay, because in this case we are getting CO or CO2. Here it will get CH2. CH2 stability is less. It is what? Less stable. And if it is less stable, the reaction would not like to proceed to forward direction. Simple. Now let's move to next question. Okay, let's see this one. Match the column 1 with the column 2 and mark the appropriate choice. Okay, electrical industry basically uses copper, right? Because copper wire is used in electrical industry because copper is a very good conductor of electricity. Yeah, batteries are used in zinc basically are used in making battery, zinc electrode basically, because zinc has very high tendency to get oxidized, to go to zinc 2 plus and produce 2 electron, and that will result into current. Next, gutter pipes. Basically gutter pipes are made up of cast iron, okay, low quality iron, that is 4. And the last one we had chocolate wrappers. Chocolate wrappers basically is very thin foil of aluminium, that is 2. So A is matching with 3. Only one option we are getting, that is the fourth option. That is correct. Okay, so I think all of the questions we have discussed, and that's all for today. Thank you.